The topic is linear probing. It is a collision resolution technique. In the previous video we saw chaining. Now this is linear probing. So this is another technique, that is linear probing. This comes under closed hashing. So we'll try to utilize the space given for hash table only, will not consume any extra space. So first I'll explain you what does it mean by linear probing. Then in that I will explain these operations: insert, search, and we will do analysis on search. Then also we'll see delete. Now let me explain linear probing. So for explanation, already I have taken a key space, that is set of keys, and a hash table of size 10, and the hash function is h of x equal to x mod 10. But we will be using modified hash function for linear probing, that is h dash of x. That is h of x plus f of I, then result mod by 10. What is f of I? F of I is equals to I. What is I? I takes the values starting from 0, 1, 2 onwards. Now I will show you how to insert these keys. Inserting these keys procedure is very simple. Now without using that function, directly I will use this function and I explain you. Then I'll explain you how we are actually following that function. So let us start. First key is 26. 26 mod 10 is 6, so it will get stored here. So there is nothing here. It is free, empty. So 26 is stored here. So we are not forming a linked list like in chaining. This is a place for storing a key. So we have stored it. The next is 30 mod 10 gives 0. So 30 is stored here. 45 mod 10 gives index 5. So 45 is stored here. Then 23 mod 10 is a 3. So 23 is stored here. Now next, observe this. 25. This is a collision. So after inserting few keys, I got a collision here. See, 25 is mapped here only, but this place is already occupied. Then I cannot have two keys at same place. Then do what? It's linear probing, open addressing. So try to store it at a next space. Again there is a key available there. It's not free. So okay, try to store it at next space. Yes, this is free. So 25 is stored here. See, 25 was mapped here, but there was no place here. So no place here. This was vacant, so we have used this one. So this is linear probing. So after how many collisions we got that free space? 2 collisions. So after 2 probes, we got a free space. So it's very simple. Whenever there is a collision, try to store an element at a next free space. Now let me show you how that function is used, what that function says. For 25, let us do it. H dash of 25 is h of 25 plus f of 0 mod 10. So result is 25, h of 25, this is the hash function. Result is 5 plus f of 0. F of I is I, right? F of I is I. So this is 0 only. 0 mod 10. So answer is 5. So this has given index 5. But there is a collision. We have used that function, right? So collision. Then next what we'll do? H dash of 25 we will calculate once again. H of 25 plus f of 1 this time, right? I value is taking from 0 onward. So first 0 we tried, then next 1 mod 10. So this is 5 plus f of 1, that is f of I is I. So if 1 is 1 only. So this is 1 mod 10. So the result is 6. Check at index 6. Already key is there. It's not vacant. Then try next value of I. Then h dash of 25 is h of 25 plus f of 2 this time. F of 0, f of 1, then f of 2 mod 10. This is 5 plus this will be 2 mod 10 is 7. Yes, check at 7. There is no collision, so we store this. So this how this function is computed more than one time. First time collision, second time collision, third time we got a space. So instead of following that function step by step, just I said store it at next free space. That's what the function is saying. Now let me insert remaining keys. 43, it is mapped here. there is a collision. So we use that same function, f of I value 0, there is a collision. Then calculate with I value 1. Next place, yes, it is free. So store 43 here. The next 74 is mapped here, already occupied. The next occupied, next occupied, next occupied, next, yes, this is free. So 74 will come here. See, very long distance. Actually, it was mapped at 4, but it's stored at 8. So many collisions. For storing 74, 1, 2, 3, 4 collisions. So after 4 collision, it got stored. So that's it. In this linear probing solution, there may be many collisions, right? More than one collisions are possible. And we try to probe linearly until we get a space. Now I will add 2 more keys and show you. One is 19. So 19 will be mapped here. 19 goes here. This is free. There was no collision. Now next I will insert 29. 29. Let me evaluate it here. H dash of 29 is H of 29 plus F of 0 mod 10. This is 29. H of 29 is what? 9 plus F of 0 is 0. Mod 10 is a 9 only, but there is a collision. There is a collision. Then try next value of f of I, right? Let us try that. It will be 9 plus f of 1 it will be. So 1 mod 10, that is 0. So try 0. So it's going cyclic. See, because we have given mod 10 here, 10 is the size of the table, so it will go cyclic. So try at 0. It is also occupied. Then try next one. 9 plus f of 2 you try. So 2 mod 10, that is 11 mod 10 is 1. So try at 1. Yes, it is found. So 29 is stored here. So this is how insertion is done. So I have inserted 19 and 29 to show you that the places are found circularly, right? Circularly. Though we are going linear, but once we have reached the end of a table, then again we'll start from the top. So that's all about insertion. Now let us see how to search for the keys. So for searching also we use the same hash function. This function will be sufficient for us for searching. Let us look at it. Suppose I want to search for a key 45. 45 mod 10. Go to this place. Yes, key is found. Yes, search is successful. I want to search for a key 74. 74 mod 10 gives us index 4. Is it 74? No. Is it 74? No. Is it 74? No. Is it 74? No. Is it 74? Yes. Stop. We got the key. Stop. See how many comparisons we have done. 1, 2, 3, 4, 5. 5 comparisons we have done. That's it. So this linear probing method is little time taking, right? It's not constant. It's more than constant. So it's little time taking. So search is successful. 74 is found. Let us try for a key 40. 40. Now watch this. 40. 40 mod 10. 0. Is it 40? No. Is it 40? No. Next place, it's vacant. So you should stop your search once you got a free space. If you got a free space, then you should stop. Now listen carefully. I know you got one doubt. You get the answer to it. Listen once again. When a key is being searched, use the hash function, go to that index. If it's not equal, next, not equal, empty place, stop. Empty place found means element is not there. So the method for searching is take a hash function, get the index, go to that index. Go on searching linearly until if the key is found or you got a free space. So this was unsuccessful. 40 was not found. So that's all. I have shown you how to search. Right? Now I'll come to analysis. Let us do analysis. I'll remove this and I'll do analysis. Now let us do analysis. Already in chaining I have explained you that Analysis of hashing is done based on loading factor. It is not done based on number of elements. In all the data structures, we have done it based on the number of elements, size of the input, but it is never done based on size of input. If you try to do it on size of input, then the answer is order of n always. So hashing will be same as linear search. So we'll do the analysis based on loading factor. So what is loading factor? Loading factor is number of elements or number of keys divided by the size of a table. So in my example, if you see the size of the table is 10 and the number of elements I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I calculate loading factor in my example, loading factor is 9 by 10. This is 0.9. So loading factor is 0.9 in our example. See, loading factor we got in decimal, that is less than 1. In the chaining it was greater than 1. But here the size of the table is fixed, so you cannot exceed the size. So that's why it is less than 1. Yes, always loading factor will be less than 1 only. It will be in decimal. Now one important thing, that is very important thing, that is loading factor should always be less than or equal to 0.5. It should not exceed 0.5. This point is very important to answer many doubts or clear many doubts. It means that if the hash table size is 10, you should not fill more than 5 keys. More than 5 keys, right? So whatever the size of the hash table, at most it can be half filled. You see in my example, I have size 10, but I have inserted 9 keys. That is wrong. That is wrong. For explanation purpose, I have taken small size and I have shown you more keys so I can show you various possibilities. But this is wrong. You should not have more than 5 keys. So that's it. If you have half of the table is empty, then a lot of free spaces will be there. Then while searching, if you remember, for unsuccessful search, we stop whenever we get free space. Then we can easily stop. We can get a lot of free spaces. So here in my example, I have only one free space because I have inserted 9 keys, which is wrong. Alright. So lambda should be less than 0.5. So lambda should be less than equal to 0.5, right? I think this has cleared many doubts. Then what is the time taken? Time is dependent on the loading factor. So average successful time, this is a known formula. So we don't have to do analysis. This is a known formula. Just you have to accept this formula. And average unsuccessful search time is 1 by 1 minus lambda. So these are the successful search and unsuccessful search average times for linear probing. Now, drawback of linear probing. First of all, you have to keep half of the hash table vacant, so space wasted. Yes. Second thing, lot of keys may be accumulating at one place and forming a cluster. They all are forming a single group, and that is cluster. Continuous you may have keys. So when you are searching for something, for example, if suppose 74 is not there and even 25 is also not there, assume that. Now I am searching for 34. If I am searching for 34. So for 34, you go to index 4. Is it 34? No. Is it 34? No. Is it 34? No. There is a free space, blank space. So we reach blank space, key is not found. So for searching some key that belongs to index 4, we are comparing with those keys also which doesn't belong to index 4. They belong to some other index. So different keys together may form a cluster, a block of keys at one place. So this is the drawback. We call it as primary clustering. So linear probing have a problem of primary clustering of keys, that is group of keys together at one place. Now let us look at delete. Suppose I want to delete 25. This key I want to delete. Use hash function, go to that particular index, that is 5, then start searching for 25. Is it 25? No. Is it 25? No. Is it 25? Yes, found. Then delete it. 25 is removed. So I will write it outside. This place is vacant. Is it right? Is it right? What about the 74? 74 was kept here because there was no space here. 74 actually belongs to location 4. So if this is free, then 74 should be moved here. Yes. It should be moved there. So it's not simple that you just delete a key and leave the place vacant. Now imagine if I am searching for 74, what happens? 74, 4, is it 74? No, no, free space, stop, 74 is not there. So if you don't fill this space by 74, 74 cannot be searched at all. So you have to shift this key. You have to shift that key. Shifting that key, is it that easy? No. Let us see. Suppose I am deleting 45. If 45 is gone, shall I shift this 26 above this one? No, 26 belongs to this place only. There is no meaning in shifting. So shifting is not easy. You have to check whether it belongs to that index or the next index, what it is. So there are many things. So solution for this one is, if really you want to delete, then search for the key. If it is found, then take out all the keys and insert all the keys once again. So that is called as rehashing. So the solution for deletion is not simple. When you want to delete a key, you have to adjust the rest of the keys, and there are a lot of things that you have to take care. So for that, better take out all the keys and insert them once again one by one. So this is a lot of efforts, lot of work. Yes. So that is the reason in linear probing, we don't suggest deletion of element. We don't delete the elements. We don't suggest deletion. Otherwise, what we do is, if really you want to delete it, then one thing you can do is you can have some flag to show whether this key is there or not there. So parallelly along with the table, you can have a flag and show that this key is not there. So this is there, this is there, this is there. So this is not there. So I can put a flag beside each key to show it is present or not present, if at all really you want to delete. Because rehashing is not suggested, it is time consuming. So I should say deletion is not easy in linear probing. So we don't recommend deletion in linear probing. So that's all about linear probing. Next video will look at quadratic probing. It is more similar to linear probing only with a minor difference. So that's all in this video.